All right, are there any questions on these problems? C? All right. If we were taking problem C, and we have a binomial square, so the pattern is the first term squared, so if we square 3x, square the 3, square the x, then we take the product of these terms. 3x times a negative 5 is negative 15x. If you double negative 15x, you get negative 30x. And then you take your last term, negative 5, and square it. Negative 5 squared is positive 25. Right? And so those would be the patterns that you would use. Okay. For D, again with the binomial cube, you probably don't want to organize it mentally. Like with C, it's easiest to just write out your pattern of coefficients, 1, 3, 3, 1. And then plug in your first term 3x, cube it, square it to the first, and then nothing, and take your negative 5, working from the back, negative 5 cubed, squared to the first, put addition symbols between each of those, and then simplify what you have. So as you work to simplify this, you cube the 3, 27, cube the x. Here we square the 3 and the x. And now when we multiply, if you're multiplying these through, again, these aren't necessarily a real convenient numbers to work with, but if you take, let's say, 9 times a negative 5 is negative 45, and then multiply by 3. And so if you thought of 3 times 40 is 120, 3 times 5 is 15, 120 plus 15 is 135. So you have your negative sign, 135x squared. Here you square your negative 5, it becomes a positive. So if you multiply those, once again, it's not really the most convenient numbers to work with. 3 times 3 times 25 gives you 225. It's a positive with an x. And then a negative 5 cubed is negative 125. And so the signs that need to be negative are negative. And they will take care of themselves fitting into that pattern. All right, the binomial cube at the end works the same way. It's the sum of terms, but the pattern's the same. Take your pattern of coefficients, 1, 3, 3, 1. Your first term is x. We're going to cube it, square it to the first. Our last term is 4. We're going to cube it, square it to the first. An addition symbol in between the terms. And now you just simplify what you have. So you have your x cubed as your lone term to start. There's nothing to simplify here, so 4 times 3 gives you 12. X squared. Here the 4 squared is a 16. 16 times 3 is 48. X. And then 4 cubed is 64. Again, all the signs are positives. And that would be your simplified form. All right. Questions on this? All right, there's one more type of problem that you may come across. If I ask you to solve and expand this expression, I want you just to take a moment and see if you can come up with the expanded form, the polynomial form, when you multiply these through. All right, one way that you can approach this is to distribute. If you distribute, take your x times x, gives you x squared, minus xy, minus 3x. Move to your next term, minus y squared. Oops. From this next term, you get a minus xy again, plus y squared. And then distribute your last term, you get plus 3y. And then finally, if you move to your final term of the first factor, 3 times x gives you a plus 3x, minus 3y, and minus 9. So again, I've kind of arranged these so that they're grouped together vertically in like terms, so that when I express my final answer, I get the x squared, a minus 2xy, the x's cancel, so I get plus y squared, the y's cancel, and then a minus 9 at the end. So here is my expanded form. Okay. It's okay to do it this way, but there's another way that I want to talk about, and if you can see it, it may simplify this process. And that is, if you think of several terms grouped together as one value A or B, or whatever the case might be, in this case, you see that these first two terms are identical, and then the last term just differs in sign, right? So this fits the pattern of A plus B times A minus B. It fits the sum and difference of terms pattern. And so if you think of that or can visualize that as the sum and difference of terms, then you're able to rewrite your answer in the form of A squared minus B squared, the special product form, which if you think of A as the whole expression x minus y squared, minus our B value is 3, so 3 squared. You can now, again, you have to be familiar with these patterns because you have a binomial square now. So if you take the first term squared, double the product of the term, so x times a negative y is negative xy. Double that, you get negative 2xy. And then the last term squared is y squared minus the 3 squared, which is 9. And so again, what you see is you can come up with the answer with mental calculations without having to organize too much, as long as you can visually see where those pieces or how those pieces fit together. And did everybody see what I did in that as far as the grouping goes? It won't necessarily be grouped to start with, but you want to try to recognize if you can. Okay. I want to see if you can do that with the two examples or sample problems from the book. It's still on page 24, sample problem 7. Again, here I'll post them here for you to look at. Okay, so see if you can answer those two questions. And if you can do them by grouping, that would be great. Okay, so again, if you think of this first set, x plus y is your A value, and 1 is your B value. It fits that same pattern of the sum and difference of terms, so it expands into the difference of squares. So if you take the first term, which is this binomial x plus y squared, minus your second term squared, you can now simplify and get your answer using the binomial square pattern. First term squared, double the product of the terms, x times y times 2 is 2xy, plus your last term squared, all minus 1 squared expanded gives you your constant negative 1. Okay. Same thing with the second group. If you look to group these first two terms as a single term, it becomes the sum and difference of terms once again, so the expanded form is the difference of squares. So if you take the first term squared minus the second term squared and then look to combine or continue to expand, now you have this binomial square once again, so it's the first term squared, 2 squared, x squared. Then it's double the product of the terms, so you take 2x times a negative 1 is negative 2x, double that is negative 4x. And then you have the last term squared, negative 1 squared is a plus 1. And then your final step, minus, and here you're squaring both the 2 and the y. You can reorder the terms if you wanted to. It's not necessary. As far as any order that you write them would be okay. When you're mixing variables or different variables, the standard form doesn't always fit highest power to lowest. Oftentimes it goes from the first letter of the alphabet, highest, down to the lowest, using that letter, and then the other side often works backwards, going the other direction.